Professor C.
Yes.
Um, this is Justin, by the way. I just wanted to let you know that on campus, the Wi-Fi is currently down.
Hmm. Okay. I'll make a note of that. Thank you for that.
No problem.
Let me see. I'm just trying to keep my clock showing. That's not a good one. Okay, I can see that. Okay. So yeah, we still got like about 45 seconds. Just there's one right there. For whatever reason, in my YouTube feed, a lot of content has been popping up as of late, like where people are breaking down the Matrix and it's like connections to like Christianity and honestly all religions. Like I saw this video where it was Neil deGrasse Tyson with what's Morpheus' name? Any other time I would know his name. Lawrence Fishburne, right? And they were going toe to toe to see who knew more about the Matrix as far as like that lore. And like Lawrence Fishburne was like, "You think you're gonna know more than me? And I'm the one that made the movie. Essentially, I started the movie." And Neil deGrasse Tyson's response was, "Well, you've made hundreds of movies, so I figured that somewhere you lose some of it in the sauce." So it was interesting. And I only saw like maybe a 20-minute clip. I think that was like a 20-minute clip of an hour long clip. Then another video popped up, but yeah, you know how you watch something and it kind of gives you things that are similar. Another one popped up, a guy, pretty much the same kind of analogies, just how the Matrix relates to religion or whatever. Okay, this looks good. And I think it's time. Yeah. Okay. All right, gentlemen. So yeah, just I'll make a note of the Wi-Fi thing, and but we have to press forward. So, all right. So let me see. So exam one should be available. Hope everyone had a great weekend. You know, I noticed. You know, even if you guys had to log in on your phones, that would still be acceptable. Just try to make sure your name is showing so that when I go to do attendance, you know, we'll work it out. We'll always figure something out. Okay, let me see. So exam one should be available right now. It covers chapters 1 and 2. So what we'll do this week, usually during exam week, I kind of leave one day as office hours, but this one kind of is broken up fairly evenly, and I think I'd rather do it the way I'm about to suggest. Where today we'll focus on chapter 1, all right, in review for exam 1, and then on Wednesday we will focus on chapter 2 to review for exam 1. All right. So yeah, let's just hop into it. And if you have questions, feel free to unmute yourself or type in the chat with the Q&A. We'll be sure to get it addressed. And also, you can ask questions from anything that you have access in Pearson, including your exam. So if you're working on the exam, you get stuck, you like for us to work on it together, we can work on a few questions together. Like it's. So if you have questions like that, you can ask them, and we can. And I think with your exam, you get unlimited attempts. I think there's, you know, the system is set to take your highest score, and there's only a late penalty after the due date. I think the late penalty is either 5% or 10%. Hope it's one of those two. I'm not sure which one it is. Oh man, did y'all see Captain America? But I'm not going to talk about it. I'm not going to talk about it. I'm going to give you guys a chance to watch it. But yeah, that was a lot of fun. I think I've seen it twice at this point. I went on my own on Thursday to see it, and then I convinced another group to go, so I went with them. Was that Valentine's Day? I think it was Valentine's Day. Just being silly. Okay. Okay, so let's hop over right here. Right. So what this is a exam a study guide. It's practice, so it's not graded. It's just for practice. So this study guide focuses on chapter 1, and that's what we're going to focus on today. And so basically, it's 143 questions. Again, it's just for practice. So what we're going to do here is just jump around randomly to as many questions as we can together. So this one asks us to use the chain rule to differentiate the following function. So the chain rule is what? The derivative of the outside function times the derivative of the inside function, right? So I'm definitely going to need to write this one out. Let me start by getting a copy of this guy. And we're going to hop over to our note taker. It's the note taker, like Undertaker. And so one thing I noticed is that on Netflix, they started streaming WWE. I hadn't really watched it, but that's something I grew up on. But I hadn't watched this since high school. I think I was there when it was, Mankind and Stone Cold Steve Austin. That was a lot of fun. And it's always tragic, like when, because we all know it's like rigged or whatever, and fake, but then occasionally people actually get hurt, and that's always sad. Okay, so chain rule here. The derivative of the outside function times the derivative of the inside function. So we have a radical nested within a radical. So you just do the outside function first. Let's just kind of work it. So the first we have the outer radical function. So if I go to take the derivative, the 1/2 is going to come down. The x, everything in the center stays. Now it's to the power of a negative 1/2. Okay, so that's the derivative of the outside function. Now we're going to say times the derivative of the inside function. So that first term, the derivative of x squared is what? 2x plus. Now we got to pretty much do the chain rule again. So the 1/2 comes down. Everything on the inside stays the same. And now it's to the power of a negative 1/2. Okay, so then we got to say times again. So I just ran out of space, but this is really all one line. The derivative of the inside function. So the derivative of that 2 right here is the derivative of a constant is 0. The derivative here, the 4 comes down. That becomes a negative 20 x to the power of 3. So it should be times negative 20 x to the power of 3. Okay. Now it's just a matter of trying to get it in the proper form. Let me think. That's basically in the denominator. That's a fraction within a fraction. That's in the numerator. Okay. So what I'm going to do, I'm going to glance over, and I want to see what form they put their final answer in, and then I'm going to do my best to try to match ours to theirs. Okay. So what I'm going to do, before I submit it, I'm going to click View an Example, and I just want to jump to the final result. It's 8 parts. I'm just going to jump all the way to the end. I just want to see how they submitted their final answer. If they would allow. Okay. So okay, that's fine. That's essentially what we have. Okay, so we just need to put ours in that form. So in other words, without the negative exponents. Come on. There we go. And I think I'm gonna shrink it up. Let me see. So that's in the denominator. Times. Okay, so that's up. Oh, they might want us to rationalize. I mean, okay. So something, let me think. Okay, before I do it here, I think I'm gonna write it out. I was gonna try to type it, but I'm like, no, that's not syncing. So if I keep working over here, we got that negative 1/2. So all of that is in the denominator. So we're gonna have what? 2 times the square root is gonna be what? X squared plus the square root 2 minus 5x to the 4. Like this. That's all in the denominator there. Okay. This next part is in the numerator. So we got this negative 20x cubed times this 2x plus, then we have a compound fraction, or complex fraction, basically a fraction within a fraction. So that's like a 2 times the square root of 2 minus 5x to the 4, like this. So I think they simplified it, right? Where we could distribute that negative 20 and do some simplification. And then we can take it out of the complex fraction. So don't leave it as a fraction within a fraction. Do the do the reductions or whatever, the simplification. So let's see. Let's start by distributing this guy. Okay. So it looks like we'll have a negative 40 x to the power of 4. The 2 turns the 20 into a 10. So that's going to be a minus you're going to have the square root 2 minus 5x to the 4 under 10. And then like this, 2 square root x squared plus square root 2 minus 5x to the 4. So there's a double radical there. Okay. Then we can basically separate these into two separate, man, this is like excessive. All right. So if you break it apart, because you have like a binomial divided by a monomial, so you can split it apart in the following way. Or we could multiply by 1 and using the LCD. Let me see if that's a little bit easier. We could multiply by 1 in the form of square root of 2 minus 5x over 4 over square root of 2 minus 5x. So let's try that. I think that might be a little bit easier. So I'm going to say times 1 in the form of 2 minus 5x to the 4 over 2 minus 5x to the 4. All right. Okay, I think that can pass inside. Or do we we'll probably just leave it actually? Let me think. Okay, so like this is gonna cancel this, but then there's another one. Does this help us? $40 x to the 4, 2 minus 5x to the 4, minus what, 10 over that same denominator? Rationalize. Let me see. Get rid of this. This is closer. Let me see. I want to check one more thing. View an example. Oh, yeah. I might try the way that they're doing it. Let me kind of look at the end again. So, going too far. View an example. So I'm just trying to get it into a form that they'll accept, get it down as far. Let's see, right here. Okay. So, okay, I think we had that form at one point. I think I'm gonna go back to that. Because like the less manipulations I have to do, the more likely we are to get it right. Right. Where is it? Let me think. That would be that over that. Okay. Right there. I think they pretty much stopped where we had it at the first part. And we can take it from there instead of condensing it. Yep, there it is right there. Yes. Okay. So I'm going to take it from where we did extra. We did more than we needed to do. I'm going to take it from up here. Come on. Up here at the top, right? That matches where they are at the bottom. If you move that to the denominator and then keep everything on the right-hand side, I think we can work with that. Okay, so we didn't have to do those extra steps. I'm just going to take it from the beginning. Now let's see if we can get this to work. Okay. Moment of truth. Turn this off. Okay. So now, if we take ours, that first part, let's do a fraction. The numerator is a 1. Let me see. We're going to have 2 times the square root. Let me see. It's going to be x squared. X squared plus the square root 2, the 2 minus 5x to the 4, 2 minus 5x to the power of 4. Okay, and then it's times. So I'll just put times, I guess. And then, okay, I'll do parentheses. I need to distribute that negative 20x squared. So let me see. That's going to turn into a negative 40x cubed. So negative 40x to the power of 3. And then looks like it's a minus. Now we're back to the second fraction. That turns into a 10. Let me hit my fraction button. We got the minus 20x cubed. So 10x cubed. I think on top we have a 10x to the power of 3. Bottom, we have that radical. So square root 2 minus 5x to the 4. 2 minus 5x to the power of 4. Okay. So again, this is what we had after we did the first, after we did the derivative. And the only thing that we simplified, we had a negative 20x. Is that squared or cubed? I think that's cubed. Uh-oh. If that's cubed, that needs to be 40x to the power of 4 right here. That needs to be a 4 instead of a 3. Let me see. But yeah, where we had that pretty much that first line is pretty much where they stopped. We're just matching the form that they had, right? Because because you see how quickly it was kind of disintegrating as we tried to go forward. I was like, wait a minute, that feels excessive. So I think I'm gonna just go with this. I'm just trying to check it, trying to minimize my errors. 10x cubed, The 2 is gone. 2 minus 5x to the 4. Okay, let's go with it. Let's see. Hang on. Let me go over it one more time. 2x squared, that's down. 2 minus 5x to the 4. That was a 3. 2x. 2x is correct. The 1/2 came down. You subtract 1. 2 minus 5x to the 4. And then times negative 20x cubed, right? That's a 10. That's on top of that one, right? We could factor out a negative 10 from both of those, and it would cancel that too, and it turned into like a 5. Or we could factor out a negative 2 from both of those, and it'll cancel. Well, maybe, I don't know if the negative is going to help us. But what we can do, at least factor out the 2 right here. We can cancel this 2 with factoring out a 2 from these two. This is going to turn into a 20. And this will turn into a 5. We could factor out a negative, but I don't know that that's going to help us any. Let's just try this. All right, I'm gonna see what they say. See what happens. Yeah, it's fine. I just wanted to compare it at this point. Oh, where'd it go? I think that was 126. Right here. And of course, it's whatever reason didn't save it. I'm just gonna submit it because I want to compare what we have to what they have. Okay, correct answer. The 2x, so the 10. 2x. There's something there that we're missing. That was fine. So it was just those constants. Let me see where we being led astray. We got everything else proper. I'm just trying to see if I can figure out. So that negative 20x squared, right? Oh, okay, I see what I did. When I went to take the derivative, I multiplied that whole second part by 20, where only that second part needs to multiply by 20. I totally want to do it again. I see where I made my mistake. So over here. All right, let me highlight it. I'm going to do it again because I see the error right here. When I did this derivative on the right hand side, honestly, to correct it, this parenthesis should be here, right? This 20 needs to be only multiplied by this guy and not this guy. That's where we made our error. That's what. Yeah. No. Yeah. I'm just doing it. Similar question. I think we can get it, especially since we know where the form and where to stop. So I'm gonna just run it back and try to be quick. If I don't get it on the second one, then I'm gonna just have to take the L because we need to move on. Just get a copy. Just one parenthesis off, and the whole thing is done for. Oh, okay. Let's try it again, and I'll just try to be quick this time. And we'll start here. So it's essentially the same thing with different numbers. And so like even when you're going through your exam, you know, it's a good idea to like try to take notes, write things down. You finish the exam, you get it wrong, try to correct it. Now I think when you go to take the exam again, it's going to give you a different set of questions, but you want to at least not be fooled by the same questions, right? Let's just try it one more time. So the 1/2 comes down, right? So that means we have this x to the 4 square root 2 minus 3x, and then all of this is to the power of a negative 1/2. So this is the outside function times the inside function. So we got this 4x cubed. Now the derivative here, the 1/2 comes down, 2 minus 3x to the power of negative 1/2. Now it's just this part times the inside function, which is going to be times a negative 3. Okay. So then now the parenthesis goes here, where before we were distributing that negative 3 improperly. Okay, so now we know, you know, so then you got this 2 square root x to the 4 plus square root 2 minus 3x, like this, like this, like that. That goes with that. So we're going to say times, we got this 4x cubed. I'm going to write the denominator first. 2 times the square root of 2 minus 3x under 3. I think this might be it. This is about the best we can do. I think I got my cancellations. This looks like it's the proper form. We figured out what we did wrong last time. We didn't, you know, we knew where to stop, so we didn't waste time trying to go too far. All right, let's give it a go. But that's the nature of these things. Oh, now we got to type all this in. 1 over 2 times the square root x to the power of 4 plus square root, come on, 2 minus 3x. Okay, that looks decent. Then we're going to say times, I'm going to do my parentheses, 4x to the power of 3 minus fraction, the numerator is 3, 2, okay, I think that's okay. 2 times the square root, 2 minus 3x. Okay, let's see how do we do this time. This is all right. All right, we got it that time. Yeah, so, you know, anyway, we got to the bottom of it. That's the nature of the beast. Let's do another one. Generate. So let's do question 27. And it's like, my only thing is like, I don't want to eat up you guys' time, but it is time. It's time consuming. It can be time consuming. Simplify the function algebraically and find the limit as x approaches 2. This comes from section 1.2. Let's see. What happens if can we just plug in 2? Let me get a copy of this because I think that some things might simplify. So let me see if we just plug in 2, that'll be what, a 0 on top. 4 minus 8 is negative 4, so that'd be 0 over 0. So we can't just plug in 2. But I think some things are going to cancel. So let's do some algebra. Let me get a quick copy of this guy. Let me get a copy. We're gonna hop right here. And maybe I can just keep them like this. And come on, there we go. All right, right here. So we're working with the limit, come on, as x approaches 2. Now that numerator, let's try to, can we factor this guy into something like this? This is what my intuition is telling me. It feels like we can factor, right? So because the second sign is negative, we know our signs are opposite. Two numbers that multiply to give us 8 and add to give us 2, positive 4 and negative 2, right? They multiply to give us negative 8, they add to give us positive 2. So the second one, the denominator, because the second sign is positive, we know our signs are the same. Because the first sign is negative, that tells us the larger number is negative, so then that means they both have to be negative. So it's going to be x minus, 2 and 2, I think, right? Negative 2 times negative 2 is a positive 4. Negative 2 plus negative 2 is a negative 4. Then we get some cancellations. This cancels this. Okay. So now after doing that, now we can just plug it, all right? 6, nope. Nope. Oh, double negative. Wait a minute. It looks like it blows up to infinity. Look like it's a vertical asymptote. Yeah. Right? Because now when we evaluate, it looks like y goes off to positive infinity as x approaches 2 from either side. Mm-hmm. Like when you get some number over 0, that's an indication of a vertical asymptote. I think it's going to be a vertical asymptote. So let's see. Let's hop over here. The limit does not exist. I think that's what it is. Let's go with that. That's what we're getting. Okay. All right, that was good. Let's generate. Let's go to question 65. Don't you shuck and jive. We're going to question 65. All right. All right, let's look at question 65. So let me zoom in just a little bit. That's decent. Okay. So find an equation for the tangent line to the graph of the given function. Now, there is a shortcut that can just take you straight to the equation. I don't know it off the top of my head, and I don't know if they use it here or not. I'm just going to do it manually. I think it's called like linearization or something. No, that's not what that's called. But there is a formula that you can use that'll take you straight to the equation of the tangent line. But what we can do if we want the equation of the tangent line at this point on this function. Again, the derivative gives us a slope. Then if we have a slope and a point, then we can use y equals mx plus b, or algebra. Okay, so let me just get a copy first, so that way when you're reviewing this, you'll know at least where it's coming from. The question ID is included in these little screenshots. For instance, this question is coming from section 1.4. It's question 18 from the back of that section. All right, come on. There we go. And we're gonna work over here. Come on. Thank you. Right there. Okay. So now we got some space. So let's start off by taking a derivative. Right? So f prime, of x is gonna look it's just 2x, right? So when x is 5, right? So then f prime of 5, right? Because the given point was 522. The result is what? 10. 5 times 2 is 10. So the slope of our tangent line at that point is going to be 10. All right. So now we have a slope, we have a point. So then from college algebra, we could use the point slope. Y minus y1 equals m times x minus x1. I'm just a fan of using slope intercept. Y equals mx plus b. Right. I'm just a fan of doing this. So we have our slope, which is 10. Our x is 5. We're trying to solve for b. And our y is 22. So b equals 22 minus what? 50? So what is that? 30, 28? Negative 28? So then the equation of the tangent line at this point should be 10x minus 28. Now, if we wanted to check something like this, okay, yeah, it's a parabola, right? So what we can do is graph these two on the same plane and get that point in our viewing window, and then we should have basically a parabola that's been shifted down by 3 units. And then if we look at the point 522, this line is gonna basically act as a tangent. So let's actually just do that real quick. It's not too difficult to do that. So let me see. I'm gonna open up my calculator right here. And we're gonna break it out. Okay. So then let me reload and refresh. Okay. So if I go to my y equals, the given equation is what? This x squared minus 3. Okay. And then the equation of our tangent line that we got was 10x minus 28. Okay. And then what I also want to do, I want to go to stat, and I just want to insert that point 522. 522, because we want that to show. So I'm going to go to stat plot. So second up here on the top left, I'm going to turn it on. Yeah, and I think a box is fine. And then my window, so I can see the thing, X, Y. So the X values, we can go, I guess negative 10 to 10 is fine. But, and 1 is fine there. What's our point? Yeah, that's fine. And then the Y min, if we're trying to get up to 22, we got our parameters and shift it down. So we'll go down to 10, we'll go up to 30. All right. So, and we'll let the tick marks on the y-axis go by 3s. Yeah, 3 is fine. Okay. So what we should see is a parabola or U-shaped curve shifted down by 3 units. We should see our point 522 plotted, and this tangent line should graze the curve passing through the point 522. If all that comes together, see there's the point 522, there's our parabola and our tangent line. That's about the best we can do. It's behaving like a tangent, it's grazing the curve. So then we can be confident in this result. Type an expression using x as a variable, 10x minus 28. This, what time is it? 10x minus 28. Okay, so just a funky little adventure. Let's generate. Let's go to question 115. That's down there, right here. Boom. Differentiate this function using the chain rule. Okay, I feel like we can do this one and just taking the notes without writing it. So the derivative of the outside function, especially with that first one we did, that one gave us plenty of practice on the chain rule. This question is, this is like, the other question was like this question, but times 3, right? We did it at least 2 or 3 times in that one question, right? So the outside function, we get the 1/2 that comes down. We're going to have this 8 plus 5x to the power, well, yeah, I'll just take some notes here. To the power of a negative 1/2, okay? Then we got to say times, the derivative of the inside function is what, just 5? Nope, no. It's the 5, right? I'm going to simplify it. So we're going to have a fraction. It looks like the 5 is left on top. On bottom, we have 2 times the square root. 8 plus 5x. I think that's it. Okay, let's get rid of our notes here. Okay. Generate. Okay, 14. Let's see right here. Yeah, so again, like some of these questions can be a little bit extra. Just do the best you can with them. This is why I do unlimited attempts. This is why I only do a minimal late penalty. I'm not trying to like be extra rigorous here. I'm really just trying to expose these concepts to you, and I have to make you accountable on some level, right? So if you get unlimited attempts, you're not in a proctored environment, just learn as much as you can. Like don't not learn anything. I know that's not it's not structurally, a good sentence or anything, but in other words, still try to learn as much as possible as you can, okay? Let's see. So this question comes from section 1.1, question 77. I guess that's fine. Graph the following function and then specify the limits. When necessary, state that the limit does not exist. The limit as x approaches 2 and the limit as x approaches 8. So we got a piecewise function. Just trying to think of some ways. I think I might use GeoGebra to graph this piecewise function. I'm just trying to think if I remember the details. So let me do a quick search. Let me see how to graph a piecewise function. Oh, I use Desmos, that's fine. I just need to see a quick example function. Desmos. I just want one that's typed up. Desmos, I think this one. Okay, y equals x. This was greater than. Okay, so I think you just need to create a piecewise function that matches the provided graph, black lines changing, yada, yada, yada. What seems off about this? Need more stuff below here. Okay, so we'll try something like that. We'll use this as a springboard or whatever. Let's go to Desmos. I'm going to go to the graphic calculator. Break this out like that. Not back here. Come on. All right. Okay. So let's do y equals x minus 1. I think you just do like this. When x is strictly less than 2. That looks decent. We might need to do some like plot some points or something, like for the endpoint there. But we'll get it later. Then we're going to say what y equals what 1 when x is when 2 let me see is less than or equal to x, which is less than or equal to 8. Okay. And then y equals x plus 2 when x is strictly greater than 8. X plus 2. There's a gap there. Okay. Kind of want to plot a point. What point is that? 8, 1. I want to plot the point P equal to 8, 1. And we want that one to be, that one's going to be solid, so that's fine. And then this other point over here looks like the point 8, 10. So I'm going to do a second point, call it Q. 8, 10. But we want that one to be open, an open circle. See if I can. I know there's a way to do this. Where are my shedding options? Here it is. Wait, it's okay. Okay, open circle. Kind of want it a little bit bigger. Maybe like, let's do 12. Okay, that's decent. Okay, we'll get rid of this. Okay, so here is our piecewise function. This is decent. We can see all the different components. We see the open circle. We got a little bit extra stuff going on there, but we got enough, right? So choose the correct graph below, right? So again, we just graphed it in Desmos. I guess I need to zoom out so I can see this. And you all can see it as well. Okay, so then there needs to be a closed circle. So I think D, right? D is the only one behaving properly. Okay, so I'm going to go with D. Check the answer. The limit is x approaches 2, right? So if we consider like a vertical wall going through x equals 2, notice as we come from the left, our y value is approaching 1. Coming from the right, our y value is approaching 1. So the limit as x approaches 2 of this function is going to be a 1. Because the left-hand limit equals the right-hand limit. Check. Okay. But as x approaches 8, Coming from the left, our y is approaching 1, but coming from the right, our y is approaching what, 10. So the left-hand limit does not equal the right-hand limit. So the limit is not negative infinity or infinity and does not exist. Yeah, let's just go with that. Okay, so basically, again, we graphed using Desmos and then interpreted what we were viewing. Okay. We still got a solid like 20 and 35 minutes. Give me a random number. Let's go to question 63. Graph this function. Draw the tangent lines of the graph for whose x's are okay, -1, -2, -1 is 0. Find f prime. Find f prime. Okay. I'm not going to do the limit quotient definition. I'm just going to take the derivative. Let me see. So x cubed, what if we factor out a 3? X squared plus 2x. It should be either A or D. Let me see. So for instance, when x, let's say when x is not x is 0 is the same in both cases. Let's do when x is what? Let's do when x is 2. What do we want to do when x is 1? Let's do when x is 1 and see what happens. So I'm pretty, it's either A or D because like, you know, it's a U-shaped curve. The leading coefficient is positive, so it should open upwards, so it can't be B or C. And then I'm just going to choose a test point when x is 1. So 3 plus 6 is going to give us a 9. Oh, wait a minute. No, it shouldn't. It should not open downward. Leading coefficient is positive. Oh, a 9, right? We said when x is 1, we got a 9, so it should be A. Because I think in D, when x is 1, we got the corresponding y was like a negative. So we got a y value of 9, so it should be A. Let's just go with A. Okay. Tangent line. So I'm just going to choose it based on the graph. If A was the correct graph, it can't be, I mean, in part A, if answer choice A was the correct graph, then it can't be answer choice A in this case, because that's not the right original graph. It can't be B, and it could be either C or D. But then D looks like those tangent lines are not drawn properly, right? Because the tangent line has to graze the curve at those values, and it doesn't look like that's what's happening in D. So I'm just going to go with C by process of elimination. Let's see, F prime. So I'm just going to take the derivative. I'm going to bypass the limit definition of the difference quotient. The 2 comes down, that's a 6x plus 6. 6x plus 6. And that should be it. So again, when we first introduced this, we did, otherwise what we'd have to do, you know, we'd have to expand it all the way out, do all this algebra, do some cancellation. So the more processes and steps that we're going to take, the more likely we are to make a mistake. So instead of doing all that algebra, we just use our differentiation technique, the power rule, and some difference rules and all that kind of stuff. So we just use the shortcuts that we've been talking about and practicing all the while. Find f prime of -2. So when x is -2, -12 plus 6 is -6. So when x is -2, it looks like we get a -6. Okay. F prime of -1, 0. Some f prime of 0 is 6. So these are the slopes of the tangent lines of those points. Okay, this is fine. Generate. Let's go to question 105. right here. I think I'm gonna write this one out. Wait a minute. So if we're gonna use the quotient rule, low D high minus high D low over low low. In other words, it's going to be the bottom times the derivative of the top plus the top, sorry, minus the top times the derivative of the bottom squared. So the bottom, okay, it can't be D, right? Because let me see, the bottom times the derivative of the top. D is the wrong order, so we can go ahead and eliminate D. The bottom times the derivative of the top. Okay, so they do that for all parts. Then for A, B, and C, we're going to say minus the top times the derivative of the bottom. Okay, so A is missing the low part, and I think that C is missing that as well. So the only one that has it proper looks like it's B. Bottom times the derivative of the top minus the top times the derivative of the bottom squared. Okay, check. So the derivative, okay. So the derivative of x is a 1. The derivative there is going to be a negative x to the minus 2. Okay, so we can take some notes here at least. We can get it to show properly. Let's get rid of this, like this. We hit the fraction button, okay. So that persists. Okay, so let me see. For right now, let's keep this x to the power of negative 1 plus 3. Okay, that's a 1. We're going to say minus. We got this x. Now this derivative of this guy over here. The derivative of x to the minus 1 is going to be a negative x to the power of minus 2. And the derivative of a constant is 0, so that just goes away. Okay, we're going to do some adjustments there momentarily. And then this denominator persists for now, x to the power of negative 1 plus 3 quantity squared. Okay. Let's see. So that's really, that second term is really x divided by x squared. And it looks like it's a double negative. So then it becomes a plus x to the minus 1. So then it looks like we're going to have, let me see, 2x to the power of minus 1 plus 3, okay, over x to the power of minus 1 plus 3 quantity squared. Okay, let me get rid of my notes. I feel pretty good about this. I think I'm going to go with it. Okay. And the reason I felt confident about leaving the negative exponents because the original question had the negative exponents in it. So because we started with negative exponents, you know, it's a good chance that we can finish with it and it's okay. Okay, we got a solid, man, I keep checking the clock and it just feels like it's dragging. But I mean, I enjoy this kind of stuff, so it's like, it's okay. Generate. All right, let's go to question 103. Some questions we get through quickly and some we don't. 103 is here. Let's see. So it looks like we're going to use the product rule. First times the derivative of the second plus the second times the derivative of the first. Okay. I notice it might be a little bit small. I'll go ahead and zoom in. Sometimes if you zoom too much, it just goes haywire. I think I'm going to take my notes here in Pearson, so I'm going to give us, you know, reduce some of this clutter. I'll zoom in just a little bit more. Okay, so I'm going to take my notes here. So then the first is this guy, 3x to the power of a negative 3. So the first times the derivative of the second. So the second is going to be what, a 4x cubed minus 9x squared plus 13. Okay, so that's the first times the derivative of the second. Now we want to say plus the second times the derivative of the first. So we're going to have this x to the power of 4 minus 3x to the power of 3 plus 13x minus 5. Let me see. First times the derivative of the second plus the second times the derivative of the first. So the derivative of the first, that's going to be what, a negative 9x to the negative 4? Negative 9x to the negative 4. I think I'm just going to leave it like this. They should take this. So I'm gonna go with this. So we just did the derivation. We didn't simplify it. Okay, generate. Let's go to question 114. So if you're making your way through your homework, if you've like kind of taken the question as far as you can on your own, you've teamed up with a classmate and you guys have taken it as far as you can, and then you sought out the tutors. And so after all of that fails, that's the best time to make use of the ask my instructor. And I'll show you what I mean. So like, for instance, here's question 114. Say we were just stuck. Like I was working on my own. I got stuck. I couldn't take it any further. I teamed up with my classmate. Between us, we couldn't get it any further. The tutor couldn't explain it. So then that's the best time to use the ask my instructor. And what it'll do is take a screenshot of the question and send it directly to me, and then I'll basically load it to my tablet and do a dedicated video response. So you can make use of that as well. And you don't necessarily have to do those other protocols, but I found that students tend to be more responsive, and it kind of sinks in a lot better when you do that first, those other protocols first. When students came to me first without doing those other things, then I give the explanation, and it usually just goes over their head. But after being frustrated a little bit and doing those other things first, I get the same presentation, and they be like, "Oh, I see what I did, bro," and it clicks, right? Okay, chain rule here. So the 51 comes down, inside stays 18 minus x. Oops. Then we're going to say to the power of 50, so we got to subtract 1, times the derivative of the inside, looks like it's a negative 1. So I'm just going to put my negative here. Generate. Let's go to question 29. Right here. Battery's in low. Let me stand up. Just wake up one day and these aches and pains in your body. Like, what the fuck is this? So now I'm trying to figure out how to, like, I can move, but it's like really disrupting things that I do. So I can figure out how to like either manage it, you know. Anyway, find the limit. I think this comes from section 1.2, question 41. We might be able to just plug in here. 6 times 5 is 30, minus 3 is what, 27? 9 times 3, so 3 times the square root of 3. So this, we got 3 times the square root of 3. Again, we just plugged in and simplified. Generate. Let's go to question 94. Maybe I can do that on my other device. Question 94. Oh, this is fine. Find the derivative, so chain rule. So the 3 comes down. This x cubed minus 1 persists. Let me see. To the power of 2. And then times the derivative of the inside function. So that's what, 3x squared? 3x squared. We could condense that into 9x squared. I'm just going to go with this. Yeah. Ooh. And like for me, it's like you know how your bones feel when they need to pop? That's basically what my hip feels like, but it won't pop. And so it's just, you know, getting worse and worse and worse. I mean, it's just more uncomfortable than anything. It's just annoying. You know, that's the extent of it at this point. I know that there are like foods that I can eat that help with it and things of that nature. Question 141. But in the meantime, it's like it's disrupting my ability to go like walking and running, and I'm like, yo, I need to be running and moving. And we are down here. Okay, so this comes from section 1.8, question 47. I don't know what the BE stands for. Business economics, I think. A company determines that the monthly sales in thousands of dollars of the T months of marketing and product is given by this equation. Find S prime of 1, 2, and 5. Find S double prime. Okay, so this one is just like higher order derivatives, right? So okay, so we can type S prime here, right? Right, type in the first derivative. So that's what 6t squared. 6t squared. Let me see, that's going to be a minus 100t plus 200. I just took the derivative of the given equation. So then when t is 1, let me see, 6 minus 100, negative, what, 94? So then 106. Yeah, it's like it's a 106. The monthly sales in thousands of dollars after this many months per month. So thousands of dollars per month. And then the second derivative is going to be thousands of dollars per month squared. So then when t is 2, 4 times 6 is what, 24? I think it's just 24 because it's like we have a minus 200 plus 200. So I think that's just 24,000. Thousands of dollars per month. And then when t is 5, let me see. 500, negative 500 plus 200 is a negative 300. 25 times 6, so if we have 6 quarters, that's $1.50. So 150 minus 300 is a negative. So it looks like we're getting a negative 150. Thousands of dollars per month. Sound like it's going the wrong way. Check the answer. So the second derivative, right? 12t minus 100. 12t minus 100. So when t is 1, 90, 88. So negative 88. It should be thousands of dollars per month squared. So that's the rate of change of the rate of change, just like the acceleration. It's like marginal, probably marginal revenue is the previous, anyway, but it should be this result. So then when t is 2, 24, so 80, 76, negative 76, thousands of dollars per month squared. And then when t is 5, 60, so negative 40. Okay. So what does the answer from parts A and B say about the monthly sales after 1 month of marketing? Parts A and B. The number of sales per month. Sales are increasing. And the growth speed, I think it's slowing down. The decline is getting worse. I'm going to come back to that one. After 2 months of marketing, the sales they're still increasing. I think the growth speed is slowing. The growth is slowing down. Yeah, let's say the growth is slowing down. The growth is still slowing down. Sales are, it went negative after 5 months, and the decline is getting worse. Yeah, like this. I think this is it. This kind of makes sense. Let's go with that. Let's see what happens. Oh, that was it? Okay. See there, my ankle. I don't know if you heard that little just a moment ago. That was my ankle. All right, let's hang out for like anywhere from 5 to 10 minutes. We should be able to do another 10 minutes. Let's generate. We'll go to question 130. 30. Hopefully you guys are okay. Let me check. I mean, the chat looks okay. I hadn't seen any notifications. So I guess you guys are okay. Second derivative, right? The second derivative of y with respect to x, okay? I'm going to take some notes here. I'm going to go ahead and write out my first derivative. So my first derivative look is going to be a negative 36 x to the power of 3. That's it. So then I'm just going to put the second derivative to the side. Let me see. 90 plus 18, 108. So negative 108x squared, negative 108x squared. And I'm going to get rid of my notes. Let's just go with it. So again, we found the second derivative. So we found the first derivative, we got an answer, then we took the derivative of that, and we got this result. Generate. We go to question 28. Your mama tried to skate. Anyway, okay. Determine the following limit as x goes off to the far right or x goes off to positive infinity. So with something like this, we can factor out x cubed from all the terms. If we factor out x cubed from everything, all the terms go to 0 except the 8 and the 12, right? Because the x cubes are going to cancel. So everything falls away except for the 8 and 12. That reduces down to 2 over 3. So as x goes off to the far right, y tends to 2/3. 2 over 3. Okay. Again, what we did there, we factored out x cubed from from all terms in the top and bottom. So then those x cubes cancel. The 8 and the 12 persists. Everything else has an x in the denominator. So then when x goes to infinity, all those terms that have x in the denominator pretty much go to 0. And then the only thing you're left with is 8 over 12, which reduces down to 2 over 3. Okay. Generate. Let's go to question 56. And again, that question came from section 1.2, question 36. I think we did a question like that in the notes. So if you want to see some details similar on how to work this out, there should be something in the notes. 56, section 1.2. All right. So question 56, which is here. So the two curves below describe the number of people in two countries at time t in years. Answers parts A through D to the right. Find the average rate of change of each population with respect to time as time changes from 0 to 4. This is often called the average growth rate of A from 0 to 4. What, the slope? So what, the change in y over the change in x? So 440 over 4. 1,100, what is this? Millions of people per year. I mean, 110. I just did the 440 divided by 4. I just found the slope. And I think it's going to be the same for both because they intersect. They both cross at that same point. So I'm going to put the same result, 110. If the calculation in part A were only the one, if the calculation in part A were the only one made, would we detect the fact that the population were growing differently? No, right? The unequal rate suggests similar growth problems. The equal rates suggest similar growth patterns, right? I think it would be D. Because they both started at the same, they had the same starting point and the same, they crossed at that point 440. Then we got the average rate of change for both of them to be the same. But you can see if we continued A, that growth is growing a lot faster than B, right? So based on the average rate of change, that suggests that they're the same, but they're not the same. Hang out for like 5 more minutes. Find the average rate of change of each as T changes from 0 to 1, 1 to 2, and 2 to 3. So population of A from 0 to 1. So that one looks like just 270 millions of people per year. 270. And then B is 110. Looks like B is going to be 110 across the board. And then 1 to 2 for A. I think it's back to 110. So those both should be 110. I'm doing this right. Average. Do we need to take their average? What are we missing there? So maybe we need to do the 110 plus 270 divided by 2. So 380 over 2. That's a 380 over 2. So it's like, what, 190? Let's try 190 here. Can't see. So I took the average rate of change. Oh, no. I see what it is. Okay. So we need to go from 1 to 2, right? Okay, let me back up. For A, so if we're going from 1 to 2, so 220 minus 110, it's still 110. Oh, no. I'm looking at B. Okay. So it's 220 minus 270. What is that? A negative 50? So I think that one is negative 50, right? I was doing from 0 to 2 instead of 1 to 2. So negative 50. And I think everything else is fine. Okay. So then from 2 to 3 again, I think B is going to be 110 across the board. Okay. So as A changes from 2 to 3. So that's the pink. So we got to say what? 180 minus 220 is what? A negative 40? It's just a negative 40 there. And then as A changes from 3 to 4, we're going to say the 440 minus 180. What is that? 240, 260? I think it's just a positive 260. So that's 260, and the next one should be 110. Oh, this thing. We might have time for one more. So I guess when we take the average. So for which population is the statement, the population grew consistently at a rate of 110 million people per year, convey accurate information, and why? That's population B. Because it initially grew slower, because the average rate of change each year was 110. Yeah, we're going to go C. Okay. Let's do one more and we'll call it a day. Generate. Question 15. Right here. Okay. So a little bit of a rocky start, but the rest of them seem like they're okay. In a particular city, taxi cabs charge passengers $3.80 for entering a cab and then 40 cents for each additional 1/5 of a mile or fraction thereof travel. If X represents the distance traveled in miles, then C is the cost of the taxi fare, where the cost is going to be $3.80 if X is 0, $4.20 if it's between 0 and 2/10 of a mile, and so on. The graph of C is shown to the right. Use the graph to find each of the following limits if they exist. The limit as X approaches 4/10 of a mile from the left. So coming from the left, when X is 0.4, as they approach 4/10 of a mile, what is that? $4.60. So let's put 460. This is called a step function, this little staircase. Is that it? Let's keep going. As X approaches 0.4 from the right, so when we get just beyond 4/10 of a mile, they're charging $5. Okay. So the limit as X approaches 0.4 does not exist because the left-hand limit does not equal the right-hand limit. Okay, that wasn't too bad. All right, gentlemen. So are there any burning questions before we go our separate ways? Okay, so I'm make a copy of these notes available in just a moment, and I'll. All right, so on Wednesday we'll work on chapter 2. Just prepare for exam 1. Right, exam 1 should be available now, so it's a good idea to just go ahead and work on it again for now until Monday, a week from today. Unlimited attempts is due at the start of class on this upcoming Monday. Right, after that, then there's a late penalty. Something it's either 5% or 10%. All right, gentlemen, if there aren't any burning questions, we're going to go ahead and end the session here. Now, from one beautiful mind to another, enjoy the rest of your evening, and we'll meet back on Wednesday, same time, same place, to go cover chapter 2 review. All right, guys, take care. Peace.